Part A. Express 10 cos theta minus 3 sine theta in the form r cos theta plus alpha, where r is greater than 0 and alpha is between 0 and 90. Give the exact value of r and the value of alpha to 2 decimal places. So first let me expand the cos theta plus alpha, and then I'll times that by r afterwards. So expanding the cos theta plus alpha from the formula booklet, I'll get cos theta cos alpha minus sine theta sine alpha. Timesing that through by r gives me this. I'm now going to compare that to the original equation that I was given. So I can see that I've got the cos theta here and here, which means that my r cos alpha has to equal 10. So let me write that down. R cos alpha equals 10. Let me now do a similar thing with the second term. I've got a sine theta here and a sine theta here, which means that my r sine alpha has to equal 3. Right, now in order to work out r and alpha, I think it's useful to write these as a ratio. So dividing both sides by r, so that I can see clearly the properties of my right angle triangle that I'm going to draw. So just a little sketch of a right angle triangle where I'm going to call this alpha. So the fact that I've got a cos being 10 over r, that's telling me that my adjacent side is 10 and my hypotenuse is r. The fact that I have a sine equals to 3 over r, that's telling me that the opposite is 3 and the hypotenuse is r. So therefore I can say with Pythagoras that r squared is 10 squared plus 3 squared. So r squared is 109. So r is root 109. To work out alpha, I can say that tan alpha is the opposite divided by the adjacent. So 3 divided by 10. And so when I do tan inverse of 3 over 10, I get 16.70 degrees. So if r is root 109 and if alpha is 16.70, then I can take that original equation there and I can rewrite it as root 109 cos theta plus 16.70 degrees. That's part A. Let's now move to the rest of the question. Alana models the height above ground of a passenger on a Ferris wheel by this equation, where h is the height of the passenger above the ground t minutes after the wheel starts turning. Now, just comparing that equation with what I started with in part A, I think that might be useful, because there's a few similarities and quite a few differences. First of all, we've got this 12 at the front, so we'll need to include that. The theta has been replaced with 30t, and probably most awkward to spot is notice how the signs have flipped. Our plus 10 became a minus 10, and our minus 3 became a plus 3. So we're going to have to flip the sign of what we found in part A. So yeah, let me rewrite this model. I'm going to rewrite this 12 minus 10 cos 30 t plus 3 sine 30t. We've got the 12 at the front, that's for sure. Now I would usually want to just write out what I found in part A. But like I said, I know that that creates a plus 10 and a minus 3. So if I put a minus at the front there, that's going to create a minus 10 and a plus 3. It's going to flip those signs around like I needed. And the other change I need to make is that I need a 30t instead of a theta. This is now exactly the same as this. If I expand out this, I get this. So this is just as good for answering the rest of these questions, and better in some cases. Right, part B. Calculate, I, the maximum value of h predicted by this model. So what is the biggest that this can be? Well, let's look at this. I know that as t changes here, I know that obviously this whole thing here will change. And then when I do cos of that, that is also going to change. I am then going to be multiplying that by minus root 109, and I'm going to be adding 12. So cos, let's think about that. In fact, just to help me out, I'm going to draw a cos graph. Just to help me out and to help me explain this. So here's my cos graph. So I can see, if t was 0, for example, if I was talking about here, if this t was 0, then that would mean that cos would be 1. Sorry, let me repeat. If all of this was 0, that would mean that cos would be 1. And that would then mean that I would have, all of this would be 1, and I'd have root 109 times 1, which would be root 109, and then I would have 12 minus root 109. Now that's pretty small. I can do much better than that. If this was 90, then cos of 90 would be 0. This would be 0. I would then have root 109 times 0, which would be root 109, which would be 0. And then I'd have 12 minus 0, which would be 12. Now that's better than what I had before, but it's still not very big. Certainly not for a Ferris wheel. We can do better than that again. If this equaled minus 180, equals 180. I keep saying the wrong numbers today. If it equaled 180, then when I do cos, I would get minus 1. When I do cos, I'd get minus 1. Which, when I times that by the minus root 109, so 12 minus root 109 times minus 1 would be 12 plus root 109, which is the 22.44 meters. That is the biggest that this could possibly be. That's the biggest the height could possibly be here. When the 30t plus 16.7, when that equals 180, the cos graph is minus 1, which then, when that multiplies by the minus root 109, I get a plus root 109, which when added to the 12 gives me the maximum height of 22.44 meters. If the 30t plus 16.7, if that equaled anything other than 180, then when I did cos of that, I would not get minus 1, and therefore I would end up getting an answer that was less than 22.44. Just finishing off part 2 of this question then. To work out the value of t, I'm going to subtract the 16.7 away from both sides. So 180 minus 16.7 is 163.3, and then divide by 30. I get my answer to 2 decimal places as 5.44. That's my answer for part C. Part B. Let's now move on to part C. Part C. Calculate the value of t when the passenger is 18 metres above ground for the first time. So when is the height 18? So I'm going to go to my model and make my height 18. I am then going to subtract the 12 from both sides. So let me just give myself a bit of room. So subtracting the 12 from both sides, I get 6 is equal to minus root 109 cos 30t plus 16.7. I'll then divide both sides by the minus root 109. I'm then going to do cos inverse of both sides. And when you do that on your calculator, you get 125.08 equals 30t plus 16.7. Notice I only want the first time here, so I'm not going to draw any graphs or anything like that. I can just subtract the 16.7 from both sides and then divide both sides by 30, and I get 3.61. That's the value of t when the passenger is 18 metres above ground for the first time. Now for part D. Determine the time for the Ferris wheel to complete 2 revolutions. Now remember that both cos and sine do 1 revolution when the inside here, when this 30t is 360 degrees. Remember, both cos and sine are cyclical and have a period of 360 degrees. They repeat every 360 degrees. So for this Ferris wheel to do 1 revolution, the 30t, the inside here, we'd have to equal 360 degrees for 1 revolution. So t would be 12. For 2 revolutions then, we'll double that and get 24 minutes.